Hey guys, it's Mr. Travis, and this thing we're working on right now in Reveal, lesson 10.6, it's pretty tough. It's multiplying mixed numbers by mixed numbers. So I'm going to show you a method, the same method I showed in class, and I'm going to show you 3 variations, kind of a easier thing that can happen and something kind of in the middle and something harder, okay? So this first one is an easier way that it can happen. Let's say I have 2 1/4 times 1 1/3. Okay, so as you remember, there are different ways to do this, but I think if you follow the same pattern every time, it can be helpful. So if you start with an area model each time, I think that's a good way to start. So I'm going to make my area model. I'm going to do 2, and I'm going to break everything apart, between the whole number and the fraction. 2 1/4, and then I'm going to draw my line, times 1 1/3, and draw my line between the whole number and the fraction, okay? So then I just follow the normal system of area models. 2 times 1 is 2. And again, I'm going to assume that you know how to multiply these whole numbers times fractions and things like that. If you don't, you might go back to earlier videos that I have sent out. 1 times 1/4, anything 1 times just 1 is 1/4, the same thing. 1 times 1/4 is 1/4. Don't be confused. Sometimes people think it's like 1/4 times 1/4, which is different, right? But 1 times anything is going to be that same thing. 1 times 1/4 is 1/4. 2 times 1/3 is, right? Let's go over it. Let's just review just for a second. If I have 2 times 1/3, I've got 1/3 2 times, right? Which is really 2/3. 2 times 1/3. Another way you can think of it is 2 whole numbers, because that's a whole number here, okay? 2 whole numbers, which is 2 over 1, because that's 2 whole numbers times 1. So then if you do it that way, you'll get the same thing by multiplying across the numerators and multiplying across the denominators, okay? But either way, 2 times 1/3, you should get 2/3, okay? And then you go over here where these meet, 1/4 times 1/3. That you might want to multiply out just to make sure that you're not thinking of it wrong. 1 times 1 is 1, 4 times 3 is 12. 1/12, okay? It never hurts to go over and work it out. Work out the problem. You might be able to do it in your head, but then sometimes we make mistakes in our head, okay? So now I have to add everything up inside the area model, just like you used to with regular whole numbers. Now I have to add all these fractions up, and that's where it can be tricky, right? We know we have 2 whole numbers, but we have 1/4 plus 2/3 plus 1/12, and that is tricky, right? And that's where I recommend the magic box, okay? And you can do the magic box with really any number of fractions. We have 3 fractions. I'm going to cut it up just to make it easier to see. So I'm going to do 1/4 plus 2/3 plus 1/12. And I also like to write somewhere, I like to write the 2 that I already have. So wherever you want to do that, we could say, 2 whole numbers. And that would be 2 plus this, plus this, plus this when we get done. But make sure that somewhere that you keep up with what you already have, which is 2, okay? So this is where I do my times something equals something. You can use other methods if you know them. But times something equals something, and I figure out 4, 3, and 12. Those are my denominators, right? So I'm going to say, let's see, 4, 3, 12. Again, some of you know how to do this stuff in your head now, but it's always nice to double check. 4, 8, 12, 16, okay, 3, 6, 9, 12. So I see the 12, so I don't even have to do my 12s because I see 12, right? That's the lowest denominator that they all have in common. So that's going to be my new denominator. Okay. So then I say 4 times what is 12? 4 times 3 is 12. I put put a 3 on the top here because really I'm multiplying times 1, so I'm not changing the value. 3/3 is the same as 1. It's just so we're making the fractions look different so we can work with them. You know, like Superman and Clark Kent, they're still the same thing. 1 times 3, I can do that now, it's 3. So just find what you don't know and do it, and the rest will fill in. 3 times what is 12? 4. So I make that 4/4 because I want to multiply by some form of 1. 2 times 4 is 8. And then I have 12 times what is 12? Again, 1 times 1 is 1. All right, so now I end up with 8, 9, 10, 11, 12. 12ths, okay? When I add these up, I'm going to get 12ths. So I just 8, 9, 10, 11, 12. So I end up with 12 12ths, which as we hopefully know is the same as 1. So I already had 2. I add my 1, and my answer here is 3. 2 times 1, 2 and 1/4 times 1 and 1/3 is 3. And that makes sense, right? 2 times 1 is 2. So 2 and a little more and 1 and a little more, 2 times, so like 2.5. Anyway, it makes sense that it's 3. If you get some weird answer like 30, you've gone wrong somewhere. So that, believe it or not, that's one of the easiest ways that it can happen, okay? So let's do kind of a medium way that it can happen. Let's say we have 2 and 2/3 times 1 and 1/2. Okay? So anytime I have a mixed number times a mixed number, one thing that I can do to solve it is create an area model. Okay? So you can think of it, you've got your mixed number times a mixed number, your area model, magic box, and then whatever else you need to do to finish out the equation, right, to finish out the problem. Okay, so 2 and 2/3. I'm going to make my line here between the whole number and the fraction. 1 and 1/2. Again, cut between the whole number and the fraction. 2 times 1 is 2. I'm going to go a little faster now. 1 times 2/3 is just 2/3 because it's 1 time. All right, 2 times 1/2. So again, you're going to multiply across the top. 2 times 1/2 is 2/2, which makes sense, right? If you have 2 times 1/2, then you've got 1/2 and another half, which is 2/2. And then I have 2/3 times 1/2. I encourage you when you get to those fraction multiplying ones to go ahead and go over somewhere and multiply them out so that you don't make a mistake, because I see people make a lot of mistakes with those. Okay, 2/6. So now I've got everything in here that I need, but I have to add all these up. So this is where I go to my magic box, or whatever method you like, as long as it works every time. I'm going to put my 2 whole numbers up at the top so I don't forget. So then I'm going to say 2/3 plus 2/2 plus 2/6 times something equals something times something equals something times something equals something. Again, you can also do the method where you do 2/3 and then you find equivalent fractions like 4/6 all the way across, and the ones with the matching denominators will be your fractions. Remember I showed you that, but I usually just stick with the magic box this year. That's what most people seem to be using. So I'm looking at 3, 2, and 6, my denominators, and I need a common denominator. Looks like 6, right? Again, I can write them out like I did a minute ago if I need to. 3 times 2 is 6, 2 times 2 is 4, 2 times 3 is 6, again, 3/3, 2 times 3 is 6, and then 6 times 1 is 6, and 2 times 1 is 2. So I end up now with 6/6 plus 4/6 plus 2/6. So I can say, in my head, I can do 4 and 2. So I've got 6/6 plus 6/6. So really I have 12/6. And again, this one's not too bad because if I can divide the top by the bottom, I can just do that and find my whole number. 12 divided by 6. I can say what times 6 is 12? 2. So I go up here and I add 2 to what I already had, and I get 4. Okay? You could have thought of it different ways. You could have said, well, that makes 6/6, and that's 1. That's 6/6, and that's another one. So I could have had a whole number there and a whole number there, and I could have added those 2 whole numbers. Either way, there's different ways that your brain will probably approach this. You just need to make sure that whatever you're doing, whatever variation of this you do, that you always are able to get the right answer with it. All right, now the hardest way that it can happen is when you don't get a nice thing like that you can divide out easily. Okay, let's do 2 1/4 times 1 2/3. All right, so again, here comes my area model. I'm gonna go a little faster. 2 1/4. If it helps you, you can put a plus sign there to remember that that's what you're really doing. You're breaking these apart. 1 plus 2/3. People like to put the plus sign in there, and I think that is smart. Okay, 2 times 1 is 2. 1/4 times 1 is 1/4. 2 times 2/3, so I do 2 across the, and multiply the numerators. 2 times 2 is 4, so I get 4/3. 1/4 times 2/3. Again, I like to just double check over here. Make sure I don't make an easy mistake. 1 times 2 is 2, 4 times 3 is 12. 2/12. Okay? So again, I got to add all these up. I need my magic box. I'm going to actually, this time I'm going to go to a new whiteboard because I think I'm going to need it. See if I can fit all this on the screen. Yeah, here we go. All right, magic box. Does that all fit? Kind of. All right, so this is where I already have a 2. It's not always going to be 2. Just these problems were like that, but so I'm going to do 1/4 plus 4/3. Just whatever your answers were, you just go ahead and do that. You could make changes to these, but it's probably not worth the hassle because you're going to make changes to them eventually anyway to get them simplified or whatever needs to happen. Times something equals something, times something equals something. Okay, I can say 4, 3, and 12. My denominator is 12. Okay, 4 times 3 is 12. 1 times 3 is 3. 3 times 4 is 12. Make that 4/4. 4 times 4 is 16. And then 12 times 1 is 12, so 2 times 1 is 2, okay? So that's what we have now to add to our 2 whole numbers. We've got 3/12, 16/12, and 2/12. So I could say 16, 17, 18, 19, 20, 21, 21/12. So now I ask, can I divide 21 divided by 12 and get a whole number? No, that won't work, okay? So here's what we do when we run into that problem. And we've done this a little bit before when we were working with fractions earlier. You can take away, since you have an improper fraction and we need to fix that, you can take away some version of 1 from this because we've got more than 1, right? 21/12 is bigger than 1. So I can take away 1. What's that going to look like? Well, in this case, 12 on the bottom, which means it has to have 12 on the top to make 1. I'm going to put a big rectangle around it to remind me that that is 1 that I'm taking away because that is going to be added to what I already have, that 2. Okay, I know this is a lot. Okay, so 21, so I'm still going to be dealing with 12s. 21 minus 12. What I do in a situation like this, I usually go back by 10 and then by 2. That's easier for my brain. 21 minus 10 would be 11, right? And then just go 2 more, 10, 9. 9, 12. So we already fixed our problem, okay? Sometimes you'll have to do this more than once, minus 12/12 and get your answer, minus another 12/12. You keep doing it until you get something that's smaller than 1 here, okay? So I already had 2. This is another whole number, plus 1, plus 9/12. So I end up with 3 and 9/12. Okay? So when you end up with a difficult number down here, or a difficult fraction that is larger than 1, and you need to get as many whole numbers as you can, and this works anytime you have an improper fraction, actually. You can just take away some version of 1, which in this case would be 12/12, because 12 is the denominator here, and keep doing it until you get down to something that's smaller than 1. And then every time you made 1, you add that to your whole number, right? Because that's a whole 1 that we took away. We got to put it back somewhere. So if I have 1, 12/12, and then I do another one, that's 2, and then I do another one, that's going to be 3. So each time I do that, that's another whole number that gets added to my answer. Okay, so hopefully that will help you with lesson 10.6 because it is definitely a tough one. So there you go.